Good morning. This lesson is for my Integrated 1 classes and my Honors Integrated 1 classes. But before I get started, I want to say I hope that everyone's doing all right out there. I'm not sure how I'm going to title this lesson, but I'm going to title it how I title it in the title. But what I am sure of is our one goal for the day. And our first and only goal is to use exponent rules to simplify radicals. Now let's quickly review the exponent rules that we're going to need to simplify radicals. Our first rule is a to the power m raised to the power n, and what that means is we're going to multiply exponents. The second rule that we're going to use is a to the power m times b to the power n raised to the power r, which means that we're going to distribute this exponent to both exponents and get a to the power m times r times b to the power n times r. Our third rule, which you're probably not aware of, but a radical has an exponent value of 1/2. And the last rule is if I put a number in the front, which is called an index, but don't worry about that. What this is saying is the nth root is equal to 1 over n, or 1 over, is equal to 1 over the n power. Words working here. All right, so I wrote down some steps to kind of help us use exponent rules to simplify radicals. Our first step is going to be to factor the number down to primes and rewrite using exponents. The second thing that we have to be aware of for most problems, if the exponent is odd, rewrite it as an even and 1. And what I mean by that, let's say that we have 5 to the power 7, which is a really large number, but let's just say we have 5 to the power 7. I have it as an odd, so we're going to rewrite it as 5 to the power 6 times 5 to the power 1. All right, now I didn't want to include that in the exponent rules because it would have been a little complicated, but this is what we're going to do if we end up with an odd exponent for most problems. The third rule is we're going to use the Beyonce rule. And the Beyonce rule is the following. All the single exponents, all the single exponents, all the single exponents to the right, to the right. And you'll see how we use that in these steps. And the last step that we're going to use is we're going to use the exponent rules to simplify. Now, one thing, again, we are very Pavlovian, which means we have that we're trained to see these rules from the left to the right. But we can also use the rules from the right to the left, and I will highlight when we're doing that. So without further ado, let's just jump into these examples, and I have basically an example of each potential type of problem that you can encounter when we use exponent rules to simplify radicals. All right, first problem. Square root of 81, I want to rewrite it as prime, factor down to primes and rewrite using exponents. So 81 turns into 9 and 9, and that turns into 3 times 3, and this turns into 3 times 3. So the square root of 81 now is going to be rewritten as the square root of 3 to the 4th power. All right, I have rule 3. I have a radical, and I'm going to rewrite it as a parenthesis to the 1/2. Okay. Now, I have exponent rule 1, so I'm going to multiply these exponents. Half of 4 is 2, and 3 to the power 2 is equal to 9. So this is what I'd like to see. I want to see the rules being used to simplify this. We know that the square root of 81 is 9, but I want to see how you can use exponent rules to get to that. All right, so that's one type of problem. The next type of problem would be something like the square root of 100. Now you know it's going to be 10, but I want to show you how to use exponent rules to simplify it. So 100 turns into, we'll say 2 and 50. 2 and 25, and 5 and 5. All right, so I want to keep my bases together here. So I have 2 2s and 2 5s. So 100 is going to turn into the square root of 2 squared times 5 squared. Now again, like before, I have rule 3, so I'm going to replace my square root with a parentheses to the 1/2 power. So I get 2 squared times 5 squared to the 1/2 power. I read that better. I'm having a hard time writing today. All right. Look, I have now rule 2. So what I'm going to do is I'm going to distribute the exponent on the outside of the parentheses, period 0 starting, to my exponents inside. And so we get 2 to the power 2 times 1/2 and 5 to the power 2 times 1/2. Half of 2 is 1, so we're going to get, 2 to the power 1. Half of 2 is 1, so we're going to get 5 to the power 1. And 2 times 5 is going to get us to 10. All right. And again, this is how we would use exponent rules to simplify radicals. I was going to ask if there's any questions, but there's no one in here. It's just myself. Moving on to the third type of problem that we can encounter when we're using exponent rules to simplify. Again, let's factor down our primes and rewrite using exponents. 8 will turn into 2 and 4, which will turn into 2 and 2. You got to keep factoring. You can't use a 4. You can break it down. And remember, I didn't remind you of this, but a prime is a number that's divisible by 1 in itself. So you have to keep breaking the number down until you can't go any further. All right, so I wrote that 5 a little close. So 8 is going to turn into the square root of 1, 2, 3, 2 to the 3rd power. Now, if the exponent is odd, rewrite as an even and 1. So what we're going to write this as the square root of 2 squared times 2 to the 1 power. Now, just like before, we're going to use rule 3. We're going to rewrite the radical as a parenthesis to the 1/2 power. And we have 2 squared times 2 to the 1. And just like before, I can distribute this exponent on the outside of the parentheses to the exponents inside. And we get 2 to the power 2 times 1/2 and 2 to the power 1 times 1/2. All right, half of 2 is 1. So we get 2 to the power 1. Half of 1 is a half, so the 2 to the power 1 times a half. And so like I mentioned, we have to use some of these rules starting from the right and going to the left. So if I have a 1/2 exponent at the end, I have to put that number back in the radical. So our final answer is going to be 2 to the power, or 2 times radical 2. Because again, if I have a 1/2 exponent at the end, that number has to go back into the radical. Okay, so that's going to be how we simplify problem 3 using exponent rules. Now this one again had an odd exponent. That's what was different from these. Now, remember, square roots are basically a number times itself, right? And if you think about it, a 1/2 exponent kind of makes sense because that's a way to cancel out a square, right? So it makes some sense if you think about why it's an exponent of 1/2. It has to cancel out squares, right? Because 9 times 9 is 9 squared, and that's 81, and we have to cancel out the square to get the square root. All right, moving on to problem number 4. We have the square root of 20, and again, I'm going to factor my number down to primes and rewrite using exponents. You know what? I forgot to mention, I use the Beyonce rule here, right? Because I split this into split this odd into an even one, and I use the Beyonce rule by putting all the single exponents, all the single exponents, all the single exponents to the right, to the right. Okay, so 20 turns into 4 and 5, and that turns into 2 and 2. So I'm gonna have a single exponent here, so I need to use the Beyonce rule. All right, so 20 is going to turn into the square root of 2 squared, because I have 2 2's, and since I have 1 5, I have to use the Beyonce rule and put all the single exponents, all the single exponents, all the single exponents to the right. And now I'm going to replace my radical with the parentheses to the 1/2 power. So we get 2 squared times 5 to the power 1. We're going to now distribute this exponent to these exponents, and we get 2 squared times 1/2, 2 to the power 2 times 1/2, times 5 to the power 1 times 1/2. Half of 2 is 1, so we get 2 to the power 1, and half of 1 is 1/2, or 1 times 1/2 is 1/2. And again, like before, if we get to the end of the problem and we have a 1/2, that number has to go back into the radical. So we're going to get 2 times the square root of 5. That is the simplified version. We don't have to put that out there. That is the simplified version of the square root of 20. All right, example number 5, the square root of 60. So let's see here. You're going to be 10 and 6, 2 and 5, 2 and 3. Now, you could have factored this down differently. It could have been true for any number. Like, we could have gone 10 and 10, or 3 and 27. 2 and 4 are the only ways to factor that one down. We could have gone to 2 and 10. And I'm mentioning this because when you break these down all the way, you're always going to have the same number of primes. So if I would have gone 20 and 4, after I would have broken everything down, this is what 20 and 5, I'm sorry, I need to learn how to do my math. This is what I would have got after I kept going over the primes. So it doesn't matter how you break the numbers down, the primes will always be the same. Okie dokie. So let's see here. I have 2 2's, so I have the square root of 2 squared. I have 1 5 and 1 3, so I need to use the Beyonce rule. All the single exponents, all the single exponents, all the single exponents to the right. Okay, so now I can replace my radical with a parentheses. Let's see here. Parentheses 1/2 power 2 squared times 5 to the power 1 times 3 to the power 1 to the 1/2 exponent. So again, like before, I can distribute this exponent to these exponents. Let's see here. I get 2 squared times 1/2. I don't know why I did that. Times 5 to the power 1 times 1/2, and 3 to the power 1 times 1/2. Let me make sure I didn't go off the board. I do this every lesson. Oh, and I just barely fit. Okay, wonderful. All right, so now we have, I wanna point something out about this before we move on. We actually have this, right, where the R is a 1/2, so we can put the R on the outside. So we can rewrite this whole thing as half of 2 is 1. And again, since both of these have a half, we can put the half on the outside. And we would have 5 times 5 to the power 1, 3 to the power 1. Again, when you get to the end of the problem and you have a 1/2 exponent, you're going to put that back in the radical. So our final answer here is going to be 2 radical. 5 times 3 is going to get us to 15. Okay, so this problem, we have multiple numbers that go back in the radical. So again, it's a little hard to see, but this is actually rule number 2. And we have this, and we're going in this direction where the R's are the 1/2, the M and the N's are the 1's, the A is the 5, and the B is the 3. So we're using that rule there. All right, last problem. Now, last problem changes this. All right, if the exponent is odd, we write as an even and 1. We have to be a little bit strategic because we know at some point that we're going to be having parentheses to the 1/3 power. So earlier we just broke the odd number to an even and 1 because an even and a half cancel each other out nicely, but now we're looking in groups of 3 because we have a root 3. Alright, so we already know that 8 turns into 2 to the 3rd power, so I'll save that. And we get the 3rd root of 2 to the 3rd, and I don't need to split that up because when I rewrite this radical, I'm going to get 1/3 exponent and 2/3 on the inside. Again, I have my first rule of my exponent rules, and I'm going to get 2 to the 3rd to the 1/3 power. And again, I didn't need to split this up because I knew that this index was going to make a 1/3 exponent, and so I want groups of 3. So 1/3 of 3 is 1, and 2 to the 1 is just 2. Okay, so what I just did was I calculated the 3rd root. What number times itself 3 times is equal to 8, and that's what I did. Now you're going to be asked to do a problem, something that looks like this as well. So you're going to be asked to do the 3rd root of, I don't know, 16. And I'll tell you real quickly that this becomes the 3rd root of 2 to the 4. So you're going to have to figure out in the homework assignment how to break this number up so we can have it behave something like this. Alright, so I'm going to go ahead and end this lesson here. I did show you basically how to simplify every potential radical problem using exponent rules. Again, I'm going to end it here. I hope everyone is doing all right up there. Have a good day, everybody. Bye-bye.